Alright, now we're going to talk about the 45, 45, 90 right triangle. And to use this, what I'm going to do is I'm going to draw a square, and I'm going to draw the best approximation of a square. I'm going to use a unit square. Whenever you have like a unit square or a unit circle or anything that says unit something, what it basically means is the defining measurements are all going to be 1. So that means that's a 1, that's a 1, that's a 1, and that's a 1. So if I have a unit square, all the measurements are 1. And that's what I want in this case. Now, I have a right angle. I have two angles, or two sides that are congruent. If I drop the diagonal, I've created an isosceles right triangle. And if both sides are 90, and that's x, and that's x, 90 is equal to x plus x, so 90 equals 2x. Divide by 2, divide by 2, x is equal to 45. So I got my 45-degree angle here, I got my 45-degree angle here, I have a side of 1, a side of 1, everything's good to go. Now, to find the length of the diagonal, Pythagorean theorem, 1 squared plus 1 squared is equal to the hypotenuse squared. Because remember, it's always the sum of the legs squared is equal to the hypotenuse squared. So I get 1 plus 1 is equal to h squared, because 1 times 1 is 1, 1 times 1 is 1. 1 plus 1 is 2, so 2 is equal to h squared. Now, in order to get rid of h squared, I need to take the square root of h squared, and that's the square root of 2. So that tells me that h is equal to the square root of 2. So this is the square root of 2. So for any 45, 45, 90 triangle, our sides are going to be 1 and 1 and the square root of 2. Generally speaking, if I want to make them larger or smaller, you're still going to get 45, you're still going to get 45 and 90, and I'm just going to say 1x, 1x, and then 1x times the square root of 2 is going to be what these three dimensions are, and we just have to match them up. Again, know what side is opposite the 45-degree angle. That's an x. 45-degree angle to an x. The 90-degree angle is x radical 2. So you have to get into the habit of knowing, all right, if this is 45 degrees here, what's the side opposite? What's that value? If this is 90, what's that side opposite? If that's 45, what's that side opposite? Because that's going to lead us into some trigonometry that we're going to do. But honestly, there's your 45, 45, 90 triangle in almost pi time. It took about 3 minutes and 15 seconds. If you have any questions, door's always open. Have a great day.